Good day, everyone. I hope you are doing well and blessed wherever you are from, and then wherever you are watching as well. Now, I'm taking this opportunity again to say thank you so much for subscribing to our channel, and thank you for liking and sharing as well, and remain blessed wherever you are from. All right, this is Bongan Masango, your tutor. I'll be carrying on with quantitative aspects of chemical change. Now, today we are looking at a given equation. All right, you can see this is the formation of water. Hydrogen gas reacts with oxygen gas to give you water liquid. All right, now you can see this equation is balanced already. All right, what we have on the left hand side, we've got 2 times 2 hydrogen, so that's 4 hydrogen on the left, and then on the right you have 2 times 2, which is 4 hydrogen on the left. Okay, hydrogen is balanced. Let's look at on the left the oxygen. Okay, 1, we don't put a 1 there, but you can see there's only 1 O2, so it's 1 times 2. There are 2 oxygen atoms on the left, and on the right there's a 1 again here, so it's 2 times 1, it's 2. So left hand side and right hand side. Okay, what do we have on the left? 4 hydrogen and 2 oxygen. 4 hydrogen and 2 oxygen. Hydrogens are balanced, oxygen are balanced. So this is actually a balanced chemical equation. What are we calling these numbers here that we use to balance the equation? These are stoichiometry coefficient factors. Okay, coefficient factors, they are balancing the equation. Anyway, let's go to the question, guys. It says, given the mass, you can see the mass is 2,2 grams. Determine how many moles of water molecules will be produced, of water liquid will be produced. How many moles are we going to produce? Okay, I want to present to you a simpler way of reading this chemical equation. All right, now see there's a 2 here, there's a 1 here which we don't write, there's a 2 there that you can see. Now we are going to read this like this: 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to give you or to produce 2 moles of water liquid. Can I repeat that? 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to give you 2 moles of water liquid. Now, what is our relationship? Our relationship here is in terms of moles. All right, so we relate everything in terms of moles, the reactants and our products in terms of moles. Remember, reactants are just anything before the arrow, which is a yield sign, and then after the yield sign we have our products. So these are reactants and these are products. All right, now the question says determine how many moles of water will be produced. Okay, that's what we are looking for. But are we given water? No. So you use whatever is given to you, which is hydrogen. All right, so we are given the mass and we said our relationship is in terms of what? Moles. So what does it mean? We must get the mole or the moles of hydrogen gas. Now the number of moles of hydrogen gas is mass over molar mass. Remember the rule, this is a capital M. All right, if you are using MR, that's also fine. What is the mass of hydrogen? It's 2,2 grams over what is the molar mass of hydrogen. Remember we did this, we started with it. This is hydrogen, right? It has the 1 atom gives you 1 grams per mole, so it's going to be 1. How many atoms are we having? 2. Okay, and therefore what are you going to get now? You're going to say 2.2 over 2, you are going to get 1.1. Okay, so it's 1,1 grams. Oh, not at all. It's, sorry about that, 1.1 mole. Remember, we are looking for what? We are looking for moles here, number of moles. So the number of mole of hydrogen gas is 1.1. All right. Now, therefore, what are you going to say from here? You are therefore going to say, I'm going to look at the ratio. Okay. So the ratio, which is the mole ratio. Okay, our ratio in terms of mole. Okay, what is the ratio there in terms of mole? Now it says what? 2 hydrogen gives you 2 water. Do you see that? 2 hydrogen gives you 2 hydrogen gas. 2 moles of hydrogen gas gives you 2 moles of water. All right. Therefore, the mole ratio is what? The mole ratio is going to be 1:1. What does it mean? For every number you have for hydrogen gas is exactly the same number of moles for hydrogen. All right, so if it's 5, you will get 5. If it's 10, you will get 5. So it means for every one you have for hydrogen gas is exactly the same as molecule of water. Now, therefore, the number of hydrogen gas is exactly equal to the number of moles of hydrogen gas, exactly the same as the number of moles of water molecule. Therefore, why are we saying that? Ratio is what? Ratio is 1:1. And therefore, the number of moles of water will be 1,1 mole. Okay, this basically is not difficult. You just have to use what is given and then relate it in terms of moles, and therefore relate whatever is given to what you are looking for. Okay, and therefore if it's 1:1, 1:2, 2:1, 3:2, and so forth, then you work with cross multiplication. All right, in this case it wasn't that difficult. Okay, however, if you want to use that, you are going to say 2 is to 2. This is 2 is to 2, and therefore what are you having here for hydrogen? This is for hydrogen and this is for water. Okay, therefore what are you having for hydrogen? You are having 1.1. What are you having for water? You don't know it. Okay, so you see what's going to happen. You're going to have cross multiply here. You're going to say x times 2 will be 2x. We know our x is water, to give you 2.2. Do you agree? 2 multiplied by 1.1 and divide by 2, divide by 2. And then what are you having? You can see that your x is 1.1 moles. So therefore the x represents the number of moles of water. All right, so that's the easiest way of doing it. Okay, but if you know it's 1:1, you know it's whatever I get for the other one is exactly the same as the other one that you're looking for. Whatever I get for hydrogen gas is exactly the same as for the water molecule. Now I want us to look at the second example. Here. Okay, now still the formation of water. You are given the mass of water to be 17.2 milligram. Please take note of that, milligrams. Okay, now you have to determine how many grams or mass of oxygen is required to produce the given mass. All right, nothing is difficult here, just they are playing around with you. And then here they are saying you are given the product, you must determine the reactant. Okay, these are the reactants and these are the products. Remember that. Okay, what are we given? Mass of water. All right, now we are going to look for the number of moles of water, which will be mass over molar mass. Remember the capital M. What is the mass? It's 17.2. Now here you can You know milli means divide by 1,000. Okay, check the prefixes: milli, nano, micro, kilo, centi, hecto, pico, and all of those. And then you will see that milli represents divide by 1,000, or it simply means times 10 to exponent minus 3. Okay, the milli is replaced by times 10 minus 3. You divide by the molar mass of water. We know it's going to be, okay, I want us to do this together. All right, I know it's 18, but I want to help you. Okay, how many atoms of hydrogens? We have 2. So it's 2 times 1, 2 times 1, plus oxygen, there's only 1 atom, therefore it's 16. Okay, you can see already that it is 18. Okay, so you are going to have 17,2 divide by 1,000, and then you are going to divide that by 18. Okay, and then your answer should be 9,5. Let me write this, and then times 10 minus 4 for now. Okay, these are 5. What are we looking for? Mole. Okay, so this is the number of mole of water molecule, and then we relate. Remember now, what are we relating? We are going to relate. The question is looking for oxygen, so we are taking oxygen. You can see there's only 1. Remember, you don't write the 1 when you are balancing the equation. I'm just using it now to show you the relationship between the two. 1 mole of oxygen gas produces 2 moles of water molecule, all right, or liquid. Now 1 mole, what are we having now? What are we starting with to give you 9,555 times 10 minus 4? What did we start with? Okay, that's the question. Determine how many grams or mass is required. What do we have? Okay, how much are we requiring to produce this? We don't know. All right, and then what do? You cross multiply. You can see you're going to have 2x will give you what? Okay, 2x will give you 9,555 times 10 minus 4. You are solving for x, which will give you, you divide it by 2, you're going to get 4,778. If the question says round off to 2 decimal places, times 10 minus 4, what? Mole. Okay, therefore the number of moles of O2 will be required. It's 4,78 times 10 minus 4 mole. But remember, learners are different. Okay, someone will say, okay, if the mole ratio says 1 mole of oxygen is required to give you 2 moles, it means the mole ratio is 1:2. Okay, do you get that? So in other words, for whatever I have of hydrogen, of water molecule, it means it's actually twice that which is required. So to get this one, I'll divide by 2. Okay, because this, what I have is actually twice of oxygen. So it's up to you. You can choose the best method for you, for yourself. Now, let me just give you something to do, something to practice. Okay, let me remove that. All right, study the balanced chemical equation of the following, or for the following reaction between sodium carbonate and hydrochloric acid, and answer the questions that follows. Now, sodium carbonate reacts with hydrogen chloride or hydrochloric acid to give you sodium chloride plus carbon dioxide plus water. Okay, you can see there's a gas that is formed, and then you learn about types of reactions maybe later on. Now, let's read this equation. It says 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid. They didn't give us the phases, ignore it for now. And then 2 moles to produce 2 moles of sodium chloride. We know this is a table salt plus carbon dioxide. Okay, 1 mole of carbon dioxide plus 1 mole of water molecule. Let me repeat it. 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid to give you 2 moles of sodium chloride plus 1 mole of carbon dioxide plus 1 mole of water. Now the reaction above 10.6 grams of sodium carbonate reacts completely with excess hydrochloric acid. Well, later on, I believe, or if you already have touched that topic of excess and limiting. Excess, it means that if hydrochloric acid is in excess, it is going to remain when the reaction is complete. Now, if this is in excess, then you are going to have this to be your limiting. Okay, so in other words, it's what we say, it limits the chemical reaction. All right, just like when you are baking bricks, maybe using sand, water, all right, and a cement, and then you find that you don't have enough water. So water will limit you from baking the bricks. Okay, so we call it a limiting reagent. All right, but we'll talk about that later on. Now, in the reaction, you are told 10.6 gram of sodium carbonate reacts completely. Okay, so it's finished. All right, with excess hydrochloric acid. So all of this sodium carbonate will react. It's a limiting reagent. 1.1, calculate the initial mass. Calculate the initial number of moles of sodium carbonate. All right, can I use this space here? Now we are looking for the number of moles of sodium carbonate. Remember, okay, power went off. I hope you can still see the sodium carbonate. It's gonna be mass over molar mass. You don't have to put the subscript sodium carbonate there. What is the mass? It's 10.6. All right. Periodic table. What is the molar mass of sodium carbonate? We know sodium is 23. There we go. So it's going to be 23 plus, there are 2 of them. So 23 times 2 plus, what about carbon? We know it's 12. There you can see it. Plus 12 plus how many atoms of oxygen? 3. So it's going to be 3 times 16. So 16 times 3. Okay. All right. And then you are going to have 10.6. Okay, let me just do that. 10.6 divide by, put in bracket to protect the numbers, plus 12 plus 16 times 3. Okay, I'm getting my answer to be 0.1. 0.1. What are we looking for? Mole. Okay, so it's 0.1 mole. Now, I have got the number of moles of sodium carbonate, which is a limiting reagent. And therefore, the question wants to find out, all right, the next question, the mass. Calculate the mass of carbon dioxide produced during this reaction. All right, so they're looking for the mass of carbon dioxide. Okay, I'm going back to look at the mole ratio. What is the mole ratio between carbon dioxide? You can see here, there's a 1. You don't write when you are balancing your chemical equation. All right, which will produce 1 carbon dioxide. You see, 1 mole of sodium carbonate produces 1 mole of carbon dioxide, obviously reacting with hydrochloric acid. Therefore, the mole ratio is what? 1:1. Therefore, the number of moles of sodium carbonate